So, today I want to start looking at some formulas and calculations that we can do on a set of quantitative data. Let's say I went to the coffee shop and I asked 5 people online, how many cups of coffee do you usually drink in a day? And I want to know what the average answer is. So their responses were 4, 1, 3, 2, and 4. So the first thing I'm going to do is find the mean. This is what people most commonly are referring to when they talk about the average. And you've probably done this before at some point in your life. To find a mean, you add up all the numbers and then divide by how many you have. So I add them all up and I have 5 values, so I'll divide by 5. That adds up to 14. over 5, which works out to 2.8. We generally prefer decimals in statistics. So, the mean number of cups of coffee that people drink in this area is 2.8. We have a special formula for the mean. Why should I have a special formula for something that you might have learned how to do in elementary school? Because I want to introduce you to new notation. Wow, I took this really simple problem and I complicated it a whole lot. X is a value of the variable. Like 4, 1, 3, 2, and 4 are all possible values of x. This guy here this is the Greek letter sigma, and it means add them all up. And n is the number of values that you have. These symbols will show up over and over again in other formulas through the class. And some of these formulas will be things that are a little more complicated than taking a mean. So, be familiar with these guys. X, a value of the variable, n, the number of values that you have, and sigma, the pointy e, add them all up. Wow, red does not want to erase. Okay. We have several other measures of central tendency. The next one is we have several other measures of central tendency. The next one is the mode. Mode is the value that appears most often. Mode is for most. What is the mode of this data set? Yes, it's 4. yes, it really is that easy. Sometimes there isn't any mode. Like if this was a 5 instead of a 4, we'd have no mode. Sometimes you could have 2 modes. If we threw on a 3 at the end, then your modes would be 4 and 3. But for the most part, the mode, not really all that complicated. Now, let's look at the median. The middle number. Once again, it's not that hard to find. You line them up from smallest to biggest and circle the one in the middle. So, three is in the middle. Therefore, median equals 3. But wait, you say, this one has 5 values, so we have a value in the middle. What if we had, say, 8 values, so there wasn't something in the middle? Let's find the median of another set of data. Say, so once again, we just line them up in size order. But now the middle is between these two numbers. So you add them up and divide by 2. Which works out to 6. So that is how to find the mean, median, and mode. Now, I'm going to ask you a question that's a little bit more complicated. The mean, the median, the mode. Which is better? The answer is, it depends. The advantage of the median is that the advantage of the mean is that everybody gets counted. The advantage of the median is that it's less sensitive to outliers. Most of the time, when somebody's trying to find average, they use one of these two, mean or median. Mode is used less often. The mean counts everyone. The median is not affected by outliers. What's an outlier again? An outlier is a value that's very different from the rest of the group. For example, let's say I want to know what is the average income of people in a particular neighborhood. So I go out and I find everybody's income. We have something of an outlier here. Most of the people in this neighborhood are making in the 20s or low 30s. This guy making a whole lot more money. if you find the mean, it's going to be somewhere in the 40s. The median, though, is a much better reflection of the typical person in this neighborhood. In fact, when the government wants to study the economic situation in a neighborhood, they look at the median income, not the mean income, because it is the reflection of how a typical person in this neighborhood is doing economically. However, if the government wants to know how much total tax revenue they're going to get from a neighborhood, well, you're probably going to get more from this guy. So you'd need to look at the mean. You'd need to count everyone. So, can the mean and the median be the same number? Yes, they can. And when they are, that tells you something interesting about your data set. That tells you it's symmetric. Let's go back to some histograms. Why? Because histograms are great.